So following on from our work with the graph of y squared equals x, when we look at the graph of y equals the square root of x, which is how we would rearrange to effectively make this a function, we're really just representing 1/2 of that original graph. So if our graph looked like that, what we're doing here is just representing that top part of it. A reflection in the x-axis, obviously, if we had y equals negative the square root of x, that's going to represent the lower half of the arm. And then you can also have your reflections the other way. So y equals the square root of negative x would give us that, and y equals negative the square root of negative x would give us that part there. So it's our same transformations, just applying to different places. And it will feel very counterintuitive to be working with things like the square root of negative x, because it feels like we're square rooting a negative number. But effectively, we're just saying we need to be careful with the implied domain. So all of these are still going to represent real numbers. It's just a case of how we graph it to make sure that that's the case. The general form here is going to be y equals a times the square root of x minus h plus k, and our endpoint or vertex, or what would be a vertex if it was a parabola, is at hk. Here we're being asked to sketch the graph of y equals 3 times the root of x plus 1 minus 6. So we know that our value of h is going to be -1, and our value of k is going to be -6. So that's our endpoint, what would be the vertex. We can see this is positive. We've not reflected anything here, so we know that we are looking for the upper arm of this graph. So if we go to -1, -2, 4, 6, it's going to be about there. So we're going to have our endpoint there. We're just looking for those special features, our x and y intercepts. So let's make x equals 0 for our y-intercept. We've got 3 times the square root of 1 minus 6. Y equals that. So 3 minus 6 is just -3. So it's going to go through this point here. And then when y is 0, we've got 0 equals 3 root x plus 1 minus 6. So 6 is here. Divide by 3, we get 2 equals the root of x plus 1. 4 equals x plus 1. So 3 is going to equal x. So we're going to go through that point there. Just join up our points and make sure we pretend it's a nice parabola. It's going to go off, continuing there. So our implied domain here is that x has to be greater than or equal to -1, because past that point, we have no values, because in our equation, if it's any less than -1, we're going to be square rooting a negative number in there. In this example, y equals -2 times the root of x minus 1 plus 3. So because here we have y equals negative root x with the h's and k's and the translations, that means we know we're looking for that lower arm of our parabola. We can look for our endpoint. So hk is going to be 1, 3. So on here, we'd go up 1 and then up 3. It's about there. And we know it's going to be going down this way. So we don't need to bother looking for a y-intercept, because it's not actually going to cross the y-axis at any point. We could work out our implied domain, but we've really already done that with our endpoint here. So we just need the x-intercept. So we get 0 equals -2 root x minus 1 plus 3. 3 equals -2 root x minus 1. If we square everything here, we get 9 equals 4 x minus 1. So 9 over 4 is x minus 1. add 1 to both sides, we get 13 on 4 equals x. So it's going to be down here somewhere. We just make a little note that that's 13 on 4. This is the point 1, 3. And then we just sketch our nice parabolic curve. It can be hard to do, but as long as you've labeled your features and you sort of know what you're going for, I'm happy with that. Last example of this graph type. So we have y equals 2 minus x plus 3. And they've given us a little note here. They've just factored out negative 1 inside the graph to say that 2 minus x is the same as negative x minus 2. So what they're indicating to us here is that we have the graph of y equals square root of negative x. So we know that because there's a positive in front, it's going to be the top half of the graph, but the negative in here has reflected in the y-axis. So we're looking for that sort of graph, yeah, the top arm heading into the negative numbers. Doesn't mean the numbers are not real. It just means that our domain, we have to have negative x minus 2 be greater than 0, because that is why we don't cross the x-axis, because if it's less than 0, then our value of y is less than 0. It becomes undefined because we're trying to square root a negative number. We don't want that. So our endpoint here, if we think of it as the graph of y equals the square root of negative x minus 2, we obviously have a k value of 0 because we've added nothing on the. So we can think of this as y equals the square root of negative x minus 2 plus 3. So our endpoint is at hk, so it's going to be at 2, 3, because now we've got x minus h under the square root rather than negative h minus x. So we know where our endpoint is, 2, 3, about there. And because we know, again, what this graph looks like, which is why it's good to visualize that before you start trying to sketch, we know there's no x-intercept here. So we only need that y-intercept when x is 0. That's actually very easy to work out here. We get y equals square root of negative 0 minus 2 plus 3. So negative 2 is just the square root of 2 plus 3. So square root of 2 we know is an irrational number, but it's just going to be a little more than 3. And we have our vertex at 3 and we know it's going up, so that makes sense. So let's just put it about here and label that as root 2 plus 3. Label here as 2, 3. And have your sketch in there.